Hi YouTube people, I'm teacher Regy Safadão, and today we are going to talk about the math relations in the right triangles. Are you ready? So, join us! Hi YouTube friends, I'm teacher Regy Safadão, and today we are going to talk about the metric relations. All right, let's see our class number 1 of 5. Okay, this is our opening and our channel is Mathematics Without Frontiers, as you already know. Well, here you will have classes of physics, mathematics, and English in 2 versions. One version in English and the other version in Portuguese. All right. So let's finally start. Trigonometry, right triangles. Well, metric relations. Here we have a right triangle. Okay, C is our hypotenuse. A and B are the legs. Okay, H is the altitude. And M and N are the projections. All right. Well, let's see. C is hypotenuse. Well, hypotenuse is the largest side of the triangle, as we already know, and it is always on the other side of the right angle. A and B are the legs. H is the altitude. M and N are the projections of the hypotenuse. Okay. And the most important relation, because here we are going to get 4 relations and an extra relation, okay, which is not a metric one. But the most important relation is said Pythagorean theorem, okay, and it is the sum of the square of the legs of the right triangle is equal to the square on the hypotenuse. So A squared plus B squared is equal to C squared, okay? This is the Pythagorean theorem, the most important relation here in the right triangles. And relation 2 is C times H is A times B. Relation 3, we have 2 relations. We have 2 formulas in this relation. The first one is A squared is C times M, and the other is that B squared is C times N. And the last relation is relation 4. H squared is M times N. As I told you, the extra relation is that C is M plus N, okay? Oh, well, now we have 4 examples, okay? 4 exercises to be done. Let's see the first one, applying the formula. So the right triangles, metric relations. See, question number 1, applying the metric relations in the right triangle, find the measures for the unknown sides. This triangle is right in A. So we have here a yellow triangle. Okay, the corners A, B, and C. And don't forget, this triangle is right in. Let me get a laser pointer here in order to show you better. Well, see, the problem says that this triangle is right in A. Okay, so this is corner A, and it is right in A. So the largest side of the triangle is the hypotenuse, okay? So C is the hypotenuse. A and B are the other sides, okay, the legs. H is the altitude. And we know that 64 and 36 are the projections of the triangle, okay? So we can apply C is M plus N. A squared is C times M. B squared is C times N. And also H squared is M times N, okay? So let's start the calculations. Well, here we have C is, well, M is 64, okay? N is 36, so 64 plus 36 is 100. So C is 100 meters. All right. Now that we know C, we can find we can find A. Okay, so let's do it. A squared is 100 times 64 because C is 100 and M is 64. Well, 100 times 64 is 6,400. So we have now A squared is 6,400. And now we can take the square root of this number. Okay, so A is the square root of 6,400. That is 80. So A is 80 meters. Okay, and now we can also calculate B. Okay, so B squared is 100 times 36. Well, 100 times 36 is 3,600. Okay, and now we can take the square root of this value. So B is the square root of 3,600. That is 60. So B is 60 meters. Okay, and now finally we can see that 8 squared is 64 times 36. That is 2,304. Okay, now take the square root, and H is the square root of 2,304. That is 48. So the altitude is 48 meters. Okay, so let's check. The C, okay, the hypotenuse is 100. The leg A is 80 meters. The leg B is 60 meters. And the altitude is 48 meters. Okay, so it was question number 1. Let's see question number 2. Pay attention. Using the metric relations in the right triangles, let's calculate the length of the hypotenuse, the altitude, and the projections of the legs A and B in the triangle ABC right in A. So now we have a green triangle, and as I told you, if it is right in A, okay, the corner here is 90 degrees, okay? So let's see corner B and corner C. All right, and D, okay, because of the altitude. Okay, so one leg is 3 centimeters. The other leg is 4 centimeters. We don't know the hypotenuse. We don't know the altitude. We don't know projection M. We don't know projection N. All right. So let's solve them. Let's get them. So applying the Pythagorean theorem, okay, A squared plus B squared is C squared. We can also apply that A squared is C times M. B squared is C times N, and also that 8 squared is M times N. Okay, so now let's replace the values, okay, and do the calculations. Okay, don't forget, A is 4, so 4 squared plus B is 3 squared. Now 4 squared is 4 times 4, that is 16. 9 squared is 3 times 3, that is 9. So we have now 16 plus 9 is C squared. Okay, well, 16 plus 9 is 25. Okay, and now see what I did. I summed 16 and 9. Okay, that is 25, and I rotated the equation. Okay, I rotated the equation because I want C here on the left of my equation. Now let's take the square root. So C is the square root of 25, that everybody knows that it is 5. So C is 5 centimeters, okay? Now let's go ahead and calculate that. A squared is 4 squared. C is 5, that we already know. We calculated here. Okay, so let's calculate the value of M. Okay, well, 4 squared is 4 times 4, that is 16. All right, so 16 is equal to 5 times M. Okay, so now let's rotate the equation. You see? Because I want M on the left side of the equation. Okay, so at the same time I did the rotation, I divided the equation. I divided 16 by 5. Okay, let's divide it. 16 divided by 5 is 3.2. So M is 3.2 centimeters. Okay, let's calculate B. Sorry, let's calculate N. So B squared is 3 squared. C is 5. Well, 3 squared is 3 times 3. It is 9. Okay. So I have now 9 is 5 times N. Let's rotate the equation. You see? So N is 9 divided by 5. That is 1.8. So N is 1.8 centimeters. Now let's calculate the altitude. So the altitude is squared is 3.2 times 1.8. So 8 squared is 5.76. Taking the square root, so the altitude is 2.4 centimeters. Okay, so we've done another question. Question 2. Let's go to question 3. All right, let's see. Find the hypotenuse length C, the legs lengths A and B, and the altitude length 8 of the triangle ABC below. Right in A. So now we have, as I told you, corner A is right. Then we have corners B and corners C. Okay, this is the altitude. Okay, the hypotenuse is C. A and B are legs. 8 is the altitude. Okay, 32 and 18 millimeters are the projections. So we know the projections and we have to calculate A, B, C, and H. All right, so let's go ahead. By the extra formula, we know that C is M plus N. And also, H squared is M times N. A squared is C times M. B squared is C times N. So let's replace values. So C is 32 plus 18. Well, it is 50. So C is 50 millimeters. All right. Now let's go ahead because we already know C. Well, we can easily find the altitude. So H squared is 32 times 18. That is, okay, 576. So now we can take the square root. H is the square root of 576. So it is 24. So the altitude is 24 millimeters. Let's go ahead. So A squared is C times M. C is 50, M is 32. So 50 times 32 is 1,600. Taking the square root of this value, so A is 40. So A is 40 millimeters. All right. And now let's calculate B. So B squared is C times N. C is 50, N is 18. So 50 times 18 is 900. And taking the square root of 900, we know that B is 30 millimeters. So now we have, well, A is 40 millimeters, B is 30 millimeters, C is 50 millimeters, and the altitude is 24 millimeters. All right, let's see question D. Question 4. Well, question 4 is, in the following figure, the measures are given in centimeters. Calculate the unknown elements. Well, let's see. We have here a dark blue triangle. And also, as we already know, the corner A is the right triangle. Corner B, corner C. Okay. C, which is the hypotenuse, is 25 centimeters. Okay, one leg A is 20 centimeters. We don't know leg B. We don't know projection M. We don't know projection N. And we don't know the altitude. So we have to calculate B, H, M, and N. All right, let's go ahead. So applying the Pythagorean theorem, A squared plus B squared is C squared. And also C times H is A times B. A squared is C times M. And B squared is C times N. Okay? So let's start by the Pythagorean theorem. 20 squared plus B squared is 25 squared. Well, 20 times 20 is 400. 25 times 25 is 625. All right, so let's calculate B like this. This 400 here comes to the right side of the equation, okay? Using the opposite, negative. You know, it was positive, it comes negative, okay? The reverse operation, I remember the reverse operation. So now let's operate. 625 minus 400 is 225. So B squared is 225. And taking the square root, so B is the root of the square root of 225, that is 15. So B is 15 centimeters. Now let's go and calculate H, because we already know that B is 15, okay? So now we have to do 20 times 15 is 30, okay? And dividing 30 by 25, we know that the altitude is 12 centimeters, all right? Let's go ahead and calculate M, okay? So A is 20, and 20 squared is 20 times 20, okay? Well, it is 400, and you have to divide 400 by 25, okay? So I have 400 is 25 times M, okay? Don't forget, now we are going to rotate the equation like this. Can you see? So rotating, M comes to the left side of the equation, you see? So M is 400 divided by 25, that is 16. So M is 16 centimeters. Okay, now let's calculate N. So B is 15. So 15 squared is 25 times N. Well, 15 times 15 is 225. Okay, and now 25 is going to divide, okay, I mean 225 is going to be divided by 25. Now let's rotate the equation like this. Can you see? So N is 225 divided by 25. That is 9. So N is 9. Well, now we have that the altitude is 12 centimeters. Leg B is 15 centimeters. Projection M is 16 centimeters. Projection N is 90 centimeters, okay? So we finished our exercise. Well, this is teacher Regy Safadão. Don't forget to subscribe our channel, to share this video with your friends, your classmates, your neighbors, okay, your siblings, everybody you love, okay? And of course, give us your like. It is quite very important for our channel. All right? Thank you very much for watching our video until the end. See you. Bye-bye.
That's all, folks.